Right, new problem. Integral from 0 to 1 of 1 over root x dx. You might be wondering, why is this integral improper? You don't see an infinity here or there, or negative infinity. Well, the reason is this. Look what's happening at 0. Try plugging in 0. Your function's undefined there. Turns out you have a vertical asymptote at 0. So here's the graph of your function, 1 over root x. You're being asked to find all this area. Well, wait a minute. That might be a finite amount of area, or it might be an infinite amount of area. I don't know. So to figure out, well, how do we figure that out? Well, what we're going to do is as follows. So I'm going to redraw my graph here like that. What we're going to do is we're going to find the area under the curve out to some point B. So we're going to find this area under the curve. And what we're going to do is we're going to say, well, what happens as we move B to the left? In other words, what happens as we move B closer and closer to 0? Well, we're going to get more and more area. Well, is the amount of area we're getting going to approach a number is our question. Like if I move B over here now. So if I do this. All right. So if I move B over, I'm going to get more area. So my question is, well, as I keep moving B over and over this way, so as B approaches 0 from the right, as I take more and more area going this way, do I get a finite amount of area? Does my area that I'm getting approach a number? In other words, what we're going to do is we're going to do the limit as B approaches 0 from the right of the integral from B to 1 of 1 over root x dx. So this is the same thing as x to the negative 1/2. So if you're trying to find an antiderivative, all right, go up a power, go up to x to the 1/2. And I'll say, okay, does that work? Well, if you bring down the 1/2 power, subtract 1 from the power, you get 1/2 x to the negative 1/2. Man, I don't want that 1/2 there. Better put a 2. 1/2 times 2 gives you 1. All right, so now if you take the derivative of this guy, you do get that guy. We're supposed to plug in 1, supposed to plug in b and subtract. So we're finding the limit as b goes to 0 from the right of, all right, plug in 1. 1 to the 1/2 power, or square root of 1, is 1. 2 times 1 is 2. So we're going to get 2 minus 2b to the 1/2, or in other words, square root of b. Well, as b goes to 0, square root b goes to 0. So we're left with 2 minus 0. That's 2. Okay, so this integral is convergent. We got a finite amount of area. The area is 2.